right, this is Geometry A, Unit 8, Lesson 12, Similar Figures and Volume. This is one of my favorite concepts. It really is surprising and beautiful and deep, but hopefully you'll enjoy it as much as I do. The idea is this, and you've already seen some of it. As we double the dimensions of an object, we quadruple, that is 2 times 2, we quadruple the area. As we triple the dimensions of an object, we multiply the area by 9, that is 3 times 3, or 3 squared. As we quadruple the dimensions of an object, we multiply the area by 16. We're going to expand that into 3 dimensions now. Imagine here I've got 4 cubes, 1 by 1, 2 by 2 by 2, and 3 by 3 by 3, 4 by 4 by 4. Okay, and as we double the dimensions, let me count them here. I'm going to change colors here. Let's go to green. As we double the dimensions, you've already seen before that there are 4 squares here, right? But now there are 2 layers of that going this way as well. So 4 doubled is 8. So the volume here is 8 cubic units, as opposed to the volume here being 1 cubic unit. So it is 2 by 2 by 2, 2 times 2 times 2, or 2 cubed is 8. Here we have, as you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9. But there are 3 layers of 9. So 3 times 9 is 27. So the volume here is 27 units cubed, or 3 to the 3rd power. 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. Here you can see that there are 4, 8, 12, 16 squares on each face. But think of it, there are 4 layers going this way. So there are 4 layers, 4 by 4, or 4 by 4, which is 16. 16 by 4, which is 64. The volume here is 64 cubic units, or 4 to the 3rd power. Okay? And so the area grows with the square, the volume grows with the cube. So let's look at how we might apply this in a given situation. Okay? Let's say we have some shape, maybe a cylinder. Some cylinder shape here. Okay, and this cylinder has a height of 8 inches and a width of, say, 6 inches. And we are going to dilate by a scale factor of 1.5. So we're going to make all the dimensions 1.5 times bigger. What happens to the volume? The volume gets multiplied by 1.5 to the 3rd. So I'm going to find the volume over here before the dilation. Volume, as you recall, for a cylinder is pi r squared h. So volume is pi times r, which is 3, half of 6. 3 squared times 8. 3 squared is 9. 9 times 8 is 72. So the volume is 72 pi. The new volume, we'll call it volume prime, is going to be 72 times 1.5 to the 3rd power. 1.5 to the 3rd power. Time to bring up Desmos. Here, Desmos. Who's a good Desmos? It's not the Des least, it's the Des most. Desmos.com/calculator. And again, just a reminder, you are encouraged to use Desmos on tests and quizzes and quick checks. Okay, 72 times 1.5 to the third, shift 6, 3, is 243. 243 cubic units. 243 pi. Sorry, 243 pi, because it's times pi, 72 times pi. 72 pi times 1.5 to the third. 243 pi cubic units. And we could put in 3.14 for pi, or a better approximation, and come up with an answer that way. I want you to notice something here. 1.5 to the third power is not a terribly small number. 1.5 to the third power is 3.375, so the new volume is more than 3 times the original volume. Volume grows with the cube, so it grows much faster than surface area or length or perimeter. It grows with the cube. Okay? So that's how to find the volume. If you're given an original volume, multiply the volume by the scale factor cubed. Or if you're given a shape and need to find the volume, and then you multiply that by the scale factor cubed to find the new volume. Okay, the other kind of question you'll be given is this. You'll be given a problem in which you have 2 volumes, and you're asked to find the scale factor. So one volume, let's say, was volume 1 here is 27 cubic units, and volume 2 is let's go 64 cubic units. And what is the scale factor of the dilation? What is the scale factor of the dilation? Remember, scale factor is new divided by old. And so the ratio of volumes, volume 2 divided by volume 1, is 64 divided by 27. But we want to go back. We took the scale factor and cubed it to get that. So to go back to the scale factor, to undo the cube root, we're going to do the opposite of cubing. We're going to cube root. Cube root 64 over 27. Now you can use a calculator if you want. If you don't need an exact answer necessarily, you can do the cube root. But basically you're answering the question, what times itself times itself times itself equals the number? What times itself times itself times itself equals 64? We happen to know the answer is 4 from our previous work. And 27, the same thing. What times itself times itself times itself equals 27? The answer is 3. So the scale factor is 4/3. Scale factor is 4/3, and we get that by finding the cube root. You could also, like I said, use your Desmos calculator in the following way. There's a couple ways to get the cube root. Okay, one is CBRT, okay, and then 64 divide 27. Okay, now that is not a fraction, but you can click the fraction button and make it display as a fraction. So that's that. Okay. Another way you could do it, if you're familiar with exponents here, you can do 64 divided by 27 to the power of 1/3. And again, we get the same answer here, 1.3333, which is 4/3. Okay, so to the 1/3 power is the same as the cube root. That becomes necessary when we got to find 4th roots, 5th roots, and 6th roots. But CBRT works fine. Notice it's SQRT for square root, CBRT for cube root. You're just spelling cube root without any vowels. You're spelling square root without any vowels to get SQRT. Okay, hopefully that makes sense. So again, new to old, if you have the scale factor and need to find the scale factor of volumes, cube it. If you have the ratio of volumes and want the scale factor of dilation, you cube root the ratio of volumes to get that.